Raise your hand if you have that written on your paper, please. Yourself 3 questions. You good? The equation that involves the amounts, so the amounts are H and B. The equation that involves the amount is right here. So I write that down. B equals pi over 3 r squared H. Question? So the next step is to differentiate this equation with respect to time. So I ddt it, both sides. I'm going to go to a new page here so I can get a little more room. So let's copy this. Let's move this out of the way. Take the derivative. That was fun. So I go d over dt of v. And here I go d over dt of pi over 3 r squared h. Okay, before I take the derivative, I need to pay attention to what things are changing and what things are constant. In this problem, as the water shrinks, the radius is going to get less and less, and the height is also going to decrease. So in both cases, the height and the radius are both variables. Question. So I have to treat them as such. So I have to use the product rule. Pi over 3 is a constant. So I can write dv dt equals pi over 3. Now I must use the product rule. So I take the second h multiplied by derivative of the first. Make sure you write dt. If you write dx, you lose points. If you write dr, you lose points. Get it wrong. It's dt. Let's see, then r squared dh dt. Question. Please.
Is it okay if I know H prime?
Yes. 2 points. Anyone else? Cool. So now we have, let's see, pi over 3. Oh, pause for a second. So did you write, I'm not sure what you meant. Did you write all of this, or did you write?
Yeah, I did.
So read me exactly what you have written.
1/3 pi r squared h prime plus 2r h dr. Wait.
So read it one more time, just want to make sure.
R squared pi third r squared h prime plus 2r. I have it written back. Well, and I have parentheses.
Gotcha. So where are the parentheses?
In between pi third and r squared, and then after h.
Okay. I'm going to have you a ticket. Really good question. You are making an error that's really common. If anyone can see the error, okay, you as well. Okay.
Well, there's still dr over dt.
Right. Because we are differentiating with respect to time, when I go to take the derivative of r squared, I bring down the 2. So at this moment, I'm going to write h, bring down the 2, still have the r, the new exponent is 1, but I still have to have a dr dt. Anyone want more discussion on that? That's not new, that's just how we've always taken derivatives, so. Abby, does that make sense?
Yeah.
Okay. Okay, we're trying to find dBdt, so we have a formula for dBdt. We just need to plug everything in and then we're done, right? Our units, of course. There's a problem at this moment. Talk to each other, raise your hand if you can tell me the roadblock. Like I'm ready to finish the problem and I'm like, oh shoot, now what do I do? Yeah, we don't know. Who knows the problem? Handy. Why am I stuck? I have to do something. I'm stuck where I'm at, honestly. Sophie?
We still have two variables,
So what are they?
R and radius and height.
So hold on a second. I'm going to pay some points for this. Let me make a copy. Hold on. I think we can read the problems. Well, let's copy this over. Hold on. Let's clear that. Okay, as I read the problem, they do give me the value for dH dt, so I have that. So dH dt is equal to -3/10. The water level's falling. They say find how fast the volume is changing at the moment when H is 5. So I know, even though H is not always 5, H is changing. H is dropping. But at the moment they're interested in, that's when H is 5. So I know that. My problem is my equation was this. dV dt equals pi over 3 H2R dr dt plus R squared dH dt. My problem is I don't know the radius and I don't know dr dt. I'm missing these two. 3 points for Sophie. Please raise your hand if you knew that's what we were missing. 2 points, okay. So you simply have to figure out a way to find them. It's kind of hidden here, but this is a similar triangle situation, just like the lamppost problem. If you look at the cone straight on and ignore that it has 3 dimensions, just look at it straight on, you see a triangle within a triangle. So there's the small triangle, and then the large triangle is here. So there's a large right triangle with a small right triangle within. Question. So similar triangles again. I can make up some ratios. I can say this radius, this dimension on the small triangle, always put the variable on the top, it makes things easier. This dimension, I can compare that to this dimension. So this is known, since this is 10, this has to be 5. And I could compare this dimension on the small, that's H, to this dimension on the large, which is 10. That's how you use the similar triangles. Question. So doing our little rearranging thing like last time, we get 10R is equal to 5H. Well, we're trying to find R. So let's divide. So I just figured out R is equal to 1/2 H. Question. you need me to go through it again or different? Please.
Wait, how do we get the R5 equals H10?
So, just making a quick comparison, you simply identify that you have a large right triangle and there's a small right triangle inside. And then you just make two fractions that compare. So I said, this is R. That's like one side of the small triangle. The corresponding side of the big has a value of 5 because this was 10.
Yeah.
And so then I say I need to make that same kind of comparison with another side. So I took this side of the small, compared it to this side of the large. I will just follow that pattern. This side of the small, H, compared with this side of the large. Does that make sense?
Yeah.
2 points. 1 hour. Awesome. Okay, look here. So this makes one thing easy. We're supposed to be figuring all this out when when H is 5. So we know that at that exact moment when the height is 5, the radius is going to be 2.5, 2.5, because the radius is half the height, always. Question? We still got to find this, the RDT. This is the equation, how we do it. We just differentiate this, both sides. So it's the RDT. 1/2 is a constant. The HDT. So now I have everything I need to finish the problem. I just plug it all in. And then just quit. So dV dt is going to equal pi over 3, parenthesis, the height is 5, I have 2 times r is 2.5, the RDT is half of dH dt, right, 1/2, and I write dH dt, -3/10. Just make sure you have all the right parentheses. Radius is 2.5, that gets squared. The HDT is -3/10. Close, close. And then I make sure I write down units. Talk and raise your hand. What are the appropriate units? All you have to do is look at what you're finding. You're finding dV dt. So the units will be units of volume divided by units of time. So hands up, what are the units? Oh yeah, please.
Why is it subtracted like that?
How many saw this mistake? 3 points, 4 for Elena. Yeah, that would be very costly. Like I suddenly did all this work and I lost a point. Yeah, so don't do that. Units, what are they? Hands. Units, what are they? Hands. Go, Carson.
7 meters cubed per hour.
On the actual AP test, there'd be a little more room. So, how many knew the unit? 2 points, 3 for Carson. Question? Hurry up and press stop before it crashes again. So.